Yeah. Hello, friends. Good morning. Welcome to Embedded Pathashala. In the last video, I have given you an overview of what is Embedded Pathashala, the courses we offer, right? So, in this video, I'll be showing you in detail about the courses that we offer at Embedded Pathashala. So, let's go through the course overview first. So, we have divided the courses at Embed Pathashala into different layers. So the first level is the foundation level, where we will teach you about ARM Cortex processor, assembly language, bare metal programming, RTOS, and basic HAL layer programming on microcontroller development boards. For our courses, we will be using STM32 based development boards for easy understanding, and the datasheets they are available for STM32 boards. Once you are comfortable with foundation level, then we will teach you core system knowledge. So here you will be learning about RTOS, bootloaders, and Linux side programming like system programming, kernel development, drivers, everything. So foundation course is mandate for every student. Either you want to enter into firmware level engineers or into Linux system roles. The foundation of embedded systems is basic. It is required for everyone because here we will teach you what a processor means, what does the controller means, different peripherals, the memory layouts, linker scripts, and other things. These are the basics every firmware engineer should know. Next, core system knowledge, as discussed, RTOS, bootloaders, Linux level development, these things. So here you can choose your domain, what you want to enter into. And next is automotive. We have instructors from automotive domain. They will be teaching you concepts about AUTOSAR, CAN protocol, ADAS, and other automotive related stuff. So if your aim is to enter into automotive industry as an embedded software engineer, you can follow these courses. Next, we also have trainers from who are working on IoT side. We have instructors who are working as engineers in IoT domain, which includes protocols like Bluetooth, Matter, Wi-Fi, and Zigbee, and other communication protocols. So if your aim is to enter into connectivity side as an embedded engineer, you can follow these courses. So in all these courses, we will have requirements for a strong knowledge on processor-based development. We also have requirements who have very good knowledge on Linux. So first two courses are mandate if you are a fresher. Then later you can choose your domain, either automotive, IoT, and we are going to plan to launch power electronics and these things. So stay tuned. We will let you know once the courses are available. This is the overview of the courses that we provide. So now let's see one by one. In ARM Cortex and bare metal programming, what we will teach you. So here we will teach you the basic architecture of microprocessor, what is an ARM Cortex board, sir, and the registers, the memory maps, and the bus interfaces, reading data sheets, and documentation, basically how to understand the document and write the code, because in industry no one will sit and teach you how to write code. They will simply give you data sheets and other documentation related to board, and you should go through that one and write the code. And next, we will also teach you assembly language. Any firmware engineer should have basic knowledge on assembly language, because here you will directly write the code to interact with the low level registers. You will directly perform operations on them. So any debugging requires assembly language knowledge. Here you can see what is exactly happening and how your high level code is converted into assembly language and what operations are being performed. Next, we will teach you bare metal programming. Here, our instructors with you will open the data sheets. They will start writing the code by analyzing the data sheets, and we will execute everything on hardware. We will write code from scratch without any copy paste. So bare metal programming will teach you, once you get a new board, how to read the data sheet, how to understand the data sheet, and how to write the code according to data sheets. This you will get. Next, HAL and LL drivers. These are the next level advanced courses where we will teach you how to use HAL libraries and low level drivers that are available for the development board. And here we will navigate through the documentation available and use that documented APIs to write our code. So this is the content that we are going to deliver in this particular course. And this is other again this subdivided into other modules of courses that respective instructors will teach you. Next, RTOS. Once you are comfortable with the foundation level of the course, where you are comfortably going through data sheets and able to write the code, next we will teach you about RTOS fundamentals. So any embedded system developer should know RTOS fundamentals because here most of the embedded jobs or the embedded systems that you develop are based on the RTOS, which are real time in execution, where you will learn about different task managing, scheduling techniques, and inter-process communication. These are very high-end concepts if you are a beginner. So we will teach you in detail, like how inter-process communication works and how much timing is critical in embedded domains. These things we will see in detail in this course. Next, bootloader development. This is one of the major courses that we are going to offer you. Here, bootloader development is must for any firmware engineer. So without bootloader, there is no embedded system. So either you work or not on bootloader, you should have minimal knowledge on the bootloader development, that is for sure. So in this bootloader development, we will teach you some concepts like booting sequences, how to like masking, and these things will be there, and some primary bootloader and secondary bootloader concepts that we will teach you. And coming to this U-boot, this is one of the advanced level of this bootloader concepts, where we will teach you like firmware over the air updates and some secure boot mechanisms, these things. So you might not understand these things at this particular point, but you will understand once you start writing the code with us. Next. Now, students who are interested in learning courses on Linux, like Linux system programming, the kernel, embedded Linux, this side, we have courses for that also. So these are the at least like overview of the courses that we will be covering in Linux side. So here we will teach you about Linux system programming, kernel development, writing device drivers, bootloaders, and everything. Yeah, Linux device drivers, and this comes under kernel development basically. So we will teach you like concepts about different drivers available, how to write them, and how to port your drivers onto device. These concepts. Next, automotive. If you are a student who is interested in automotive technology, we have instructors from automotive domain who will be teaching you technologies related to automotive embedded. Like for example, AUTOSAR is mostly used in ADAS, and there will be some certifications which automotive engineers should know. Our instructors will give high-end lectures on these things. Yeah, and if you are an automotive engineer, you must be knowing of these things. So you should work on CAN protocol, CAN, LIN, and FlexRate. These are some of the communication standards and protocols that you use, and ADAS development, AUTOSAR. That in your automotive course you will learn these things. Don't worry for now, but this is what you will definitely learn. Next, IoT, which is the course which I like the most. So here we will teach you about different IoT protocols. Like here, the course is divided into two parts. One is the firmware level, where you will be writing for drivers and these things. Other is application level, where you will be developing the application level, integrating it to the cloud and receiving the data and sending data, these things. So IoT level course are very good instructors who are working in real time in wearable technology and smart home technologies. So you will learn very good concepts in IoT development. So let me show you a bit of the pathways, like what are the jobs that are available. So after these courses, you can either land in firmware engineer level roles if you are interested in microcontrollers and hardware. If you are passionate towards Linux kernel development, you can get jobs in these things. If you are an automotive engineer, who you can get as an automotive software engineer. If not, you are interested in IoT and communication technologies, you can become an IoT architect. We have different career pathways. So we will have separate career guidance for every individual module that we offer, where instructors will teach you about individual technologies. They will make you prepare for interviews. We will share some interview tips and questions, practice, programming exercises. We will have multiple hands-on sessions. So if you have any questions, you can let us know. Yeah, thank you.